All right, for B part C, we now have a 63 degrees Fahrenheit and got to work back to the Celsius temperature. So notice how we had 57 and it was 14. It's gonna be a little bit higher than that. So we'll take a look at this one here for part 3. So this is Wednesday. And we have 63 degrees. That equals what degrees Celsius? So now we're gonna put the 63 over here. We're gonna put 63 over here for our Fahrenheit degrees, 9/5 C plus 32. So this is a regular old pouches and coin situation here, guys. So we need to make sure that we're gonna look at this. We got these two coins. We need to get them together. So I'm gonna do minus 32 here and minus 32 here. This is gonna cancel. This is gonna end up being 31 equals 9/5 C. Now remember, this is like what we would look at. This is being multiplied, so we would do the opposite of dividing, but we can't divide by fractions. So what we do is we multiply by the multiplicative inverse, or multiply by the reciprocal. So take all of this, I'm gonna multiply it times 5/9. Multiply all of this times 5/9. These guys would cross cancel, so C is alone. And then over here, I'm gonna have this, I'm gonna rewrite this as 5/9 times 31/1. I can't cross cancel, so I need to multiply 31 times 5, which is gonna be 155. Then I'm gonna do that, it's gonna be 155/9. And I need to do a division problem. 155 divided by 9 goes in one time. Got 65, this is gonna end up being 7, so 63. Get a 2 decimal point coming in, bring that down. Let's go in 2 times. So it ends up being about 17.2 degrees Fahrenheit, or we might just say Celsius is gonna be 17 degrees in that case. All right, Thursday, same process, 70 degrees Fahrenheit this time. So we'll do the exact same work here for Thursday. So now I'm gonna have 70 degrees is equal to 9/5 C plus 32. Now I'm kind of I'm taking a little bit shorter steps here, but you guys know the process. Same idea. Subtract 32, subtract 32. This is gonna cancel. So I'm gonna subtract here. This is gonna end up being 38 equals 9/5 C. Same process here. Multiply by 5/9. Multiply times 5/9. These guys are gonna cancel, so I'm left with C. But then I'm gonna end up having 5/9 times 38/1. I can't cross cancel at all, so I'm gonna be moving that multiplication here. So 38 times 5 is gonna be 40, it's 50, so 190. So I have 190/9. So 190 divided by 9. So I go in 2 times. And 1 time. It's about 21.1 degrees, or Celsius would be 21 degrees Celsius. And for Friday, we've got 58 degrees Fahrenheit. So what temperature is that in Celsius? So we've got Friday. So here it is, 58 degrees is equal to, so it's 9/5 C plus 32. Same exact process that we'll be doing that. So in this case, minus 32 and minus 32, that's gonna cancel. Subtract this here, I'm gonna have, so I got 26 equal to 9/5 C. Oops, 9/5 C, that was a weird 5 there. Same thing we've been doing here, multiply all this times 5/9, multiply all this times 5/9. These guys are gonna all cancel, so I'm left with C. I'm gonna have 5/9 times 26/1. No cross canceling at all. So 26 times 5 is, this is gonna be 30, 10, so 130. So I'm gonna have a 130/9. So 130 divided by 9 goes in 1 time. It's gonna go in 4 times, it's gonna be 36, get a 4 again. Decimal point, 0, bring it down. It's gonna be another 4 times. So it's 14.4 degrees, or Celsius equals 14 degrees in that case there. All right, we're on to figure C, or part C, okay? Square tiles were used to make the pattern below. Figure 1 did this, figure 2 did this, figure 3 did this. Write an equation that gives the perimeter P of the nth figure. All right, so they're asking us for an equation, but I want to make sure I know what this data is. So I know what comes first is the figure number, and then I have the perimeter. So based on this, figure 1, figure 2, figure 3. So figure 1, the perimeter going around this would be, so here, so 1, 2, 3, 4, 5, 6. Okay, so the perimeter is going to be 6 in that case. Figure 2's perimeter is going to be, starting here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is going to be 10 here. Figure 3, starting up here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so that's what the data is giving us. And so what they're wanting us to work through and figure this whole process out is an equation. Remember, our equation has to be in the format of y equals mx plus b, where m is that rate of change and b is the y-intercept, or that slope. So let's talk about here what's happening in this case. Let's say this is going to be our x, this is our y. So remember, we're looking for the change of y. So the change of y in this case, if I go from 6 to 10 plus 4, 6 to 10 plus 4. So I'm going to have a 4 over, then my change of x. Change of x is going to be plus 1, plus 1. So I have a 4 over 1 slope in this case. So that's the starting point. So I know I have that piece there. I got this amount of a 4 for the y-intercept. So they're asking us for perimeter of nth figure. So I'm going to have P is equal to 4 times n. Now, the tricky part here is I have to go backward. What if I went back to 0 here? That means I went minus 1 this way. So what would happen here? If I did plus 1, plus 1, plus 1, I did minus 1, minus 1, minus 1, minus 1, this would be like plus 4, plus 4, plus 4. I would do a subtract 4, which would mean up here I would have a 2. That means my y-intercept would be 2. So this is the equation that we would get for C1, right? Or to compare your equation to that of your classmates or the expressions for perimeter equivalent. Well, we can't really do that very well, but hopefully you guys would all get the same thing. Number 3, is this relationship linear and explain? Well, if I look at this equation, it does follow that same model of having a slope and a y-intercept. We do have a slope and a y-intercept. So yes, this is linear. We have a slope and a y-intercept. Okay. 4. Hachi observed that there was an interesting pattern for the number of square tiles needed to build each figure. What pattern might she have observed? Okay, so now we're looking at the pattern of the tiles. Let's say look at this data. So now we're looking at number 4. So we're looking for figure number and number of tiles. So 1, 2, 3. So let's take a look. So figure 1, there are 2. Figure 2, there are 1, 2, 3, 4, 5. Figure 3, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, what pattern might she have observed? Well, I'm looking at this, and then it goes plus 3, plus 5. So that's not going to be linear. Definitely not going to be linear in this case. But if I look closely at it, you can see, I actually see if I have, like, if I cover this extra one, there's a square. Cover this extra one, there's a square. And so that one means I could be a little square. So it's all this extra little piece there. But look at this. This is a square of 9, and the sides are 3. So figure 3 is like a square made of sides of 3, it makes 9. Figure 2 is like a side with a length of 2, but makes 4 squares to make one big one. In that case, so what we actually have happening here is something that's going to be quadratic. We actually have here, in this case, that the, I think what we're saying, the tile number is equal to number of tiles squared plus 1. So we have happening. So if I put 1 in here, 1 squared is 1 times 1 is 1, plus 1 is 2. 2 squared, 2 times 2 is 4, plus 1 is 5. 3 squared, 3 times 3 is 9, plus 1 is 10. So that's what we're seeing here on this one. Write an equation, which we just did. Is this linear? So there's A, there's B, and C. No, this is a new word for you guys. This is quadratic. Okay, it's quadratic because it was non-linear in that case. Or we would say non-linear at this point.
All right, part D. Look back at the equations you wrote in question A, part 3, question B, part 1, and question C, part 1. Without graphing the equations, describe what the graph of each would look like. Which variable would be on the x-axis, which variable would be on the y-axis? Would the line have a positive slope or negative slope? Okay, so let's go back first of all to question A, part 3, which is right here. Here is question A, part 3. So first question they ask us is, what would it look like? Well, I can see that we would have the x and y axis. We'd have a y-intercept of 150, so it would go up by a little bit. It would be a slow growth, like a $5 per week growth, so it would be positive. So we'd have that. What variable would be on the x-axis? It would be the weeks across the x-axis. On the y-axis, we'd have amount of money going up there, and it would be a positive slope, okay? All right, part B, question 1, is this equation here. So same concept here. I believe this would be a positive slope. We would be going up. We'd have our same kind of working here, positive, our y-axis here. And then across the horizontal axis, we would have the degrees Celsius. Vertical axis, we would have degrees Fahrenheit. See, as our y-note, we'd go up to 0.32 and be slowly kind of going up this way in that process, okay? And C part 1, this guy here, we'd have the same concept here, okay? So it's going to be, again, going to be a positive slope. So you can see across the bottom, we're going to have the figure number. Going up this way, we'd have the perimeter. And so you can see as we would have it start up at 2, but then we go up by 4, 4, 4, 4 that way. And that's what we would have in that particular case there. Okay? D2. When is it helpful to represent a relationship as an equation, a table, and a graph? Well, honestly, guys, for that one specifically, personally, I always like the equation because I can visualize it more. But it really depends on the scenario. Sometimes when you are working through a scenario, whatever method really works best for you is the way to go. Making of the graphs takes a long time. When you actually create a table, you can visualize everything the same kind of way. But for any of those cases, I think the equation really kind of straightforward kind of helps me. But really, it's going to be your own perspective. It just depends on what you have. If you want to see a graph, you can actually look at it and you see everything you need right there. So it really comes down to whatever you think is going to work out best for you. That's what I would say for that. All right, let's take a look at the ACE work for today. We're going to be doing questions 35 through 42. Mei-Feng is taking a bike repair class. She pays the bike shop $15 per week. Okay, that sounds like a slope. At the end of the third week, Mei-Feng still owes the bike $75. So this is actually going to be like a paying. Remember how the one we had in class, it was a saving. This is paying, so this is going to be negative. It's going to be coming down. So think about how many payments does she have left, how much the class cost, write an equation for that graphic, describe what it would look like. 36. Robert's installing a patio in his backyard. At 2 p.m., he has 120 stones laid in the ground. At 3:30, he has 180 stones in the ground. He designed the patio, he'll need 400 stones. So when would you predict it would be done? What's a reasonable estimate for the time you started? If you want to know how many stones he would have in the ground at the time, it would be helpful to have an equation, a graph, or a table, and explain. Same continued process when it comes to this 37 here, a noon temperature is 30 degrees Fahrenheit. Several hours, the temperature falls by an average of 3 degrees Fahrenheit per hour. Write an equation for T within hours. What's the y-intercept? What does the y-intercept tell us about the situation? What's the slope? What's the slope tell us about the situation? 38. Damon never manages to make his allowance last for a whole week, so he borrows money from his sister. Suppose Damon borrows 50 cents every week. Write an equation for the amount of money M Damon owes his sister after n weeks. What's the slope of the graph of the equation from part A? Okay, so it's pretty straightforward. 39, a little bit of a bigger question. In 2000, the small town Cactusville was destined for obscurity. However, due to hard work by its officials, it began adding manufacturing jobs at a fast rate. As a result, the city's population grew by 239% from 2000 to 2010. What was the population? And what, suppose the same rate population increases continues, what might the population be in 2020? And then more scenarios, you got Terrence, Karina, veterinary practice, information about the phone rate, plus 50 cents a minute. All this information here, more information about figures. This time you have actually different people's perspectives on what they saw. Then you're going to talk about who's right. And then 42, more figures with those little cubes there as well.
All right, guys. We'll have this one ready to go. Keep looking back and forth at it, see what you need. But hopefully we'll see you at the Google Meet for this class as well, too. Catch you next time. Bye-bye.